All right, so now we're moving on to section C of our chapter 6, and that's going to be problem solving. All right, and this is actually the last section that we're going to cover before you guys take another test or quiz. It will be a little bit smaller than if we were doing the entire chapter unit, but it's going to just be on solving equations and problem solving, which is going to be doing word problems. All right, so this section is going to be all about word problems. So what our goals or objectives for today is to be able to translate word problems into algebraic equations without being able to look at what's given to you in the word problem and then rewrite it in mathematical terms. You'll never be able to solve it. So the first thing that you have to do is you have to work on translating the word problem, going through piece by piece and saying, how can I write this algebraically? Then the next thing is, because we've gone through multiple methods now, we're cross multiplying, we're multiplying by our least common multiple, or we need to simplify before we can solve. So there's multiple methods we've gone through in the last two sections. So now our goal is to be able to solve algebraic equations using the best possible method. So you need to be able to decipher between when should I cross multiply without me telling you this is when we do it. When do I multiply by my LCM? When do I do simplifying? So you need to be able to determine what is the best possible method for you to solve this algebraic equation. And then the last thing is, whenever we were talking about word problems before, or mainly just like translating between expressions to equations, or from words to expressions, you all kept on saying a number, a number. Well, I told you before that I want you guys to start defining your variables. So that's something I want to make sure you guys are able to do by the end of this. And then once you start defining your variables, you will never say a number ever again. You can just say X, because you say what X represents. Right? There's only a few questions, maybe 3 questions in this video, I think. After we do these 3, tomorrow in class, I will show you a separate way. Right? There's a couple ways that you can do these. I'm only going to show you one way in the video because I don't want to confuse you guys right away. And then the second way I'll show you in class. And then this way, if you have any questions, I'm there in person to help you as we go. I think the second way might be a little bit more challenging than the first, but some people might visually be able to understand it a little bit better. All right, so let's go ahead and get started on the problems. Or we're going to talk about the steps first and then get into the problems. All right, here are the steps that you'll need to follow in order to solve these word problems. So many problems can be translated into algebraic equations. And to solve problems using algebra, we must follow these steps. And step 1 is to decide on the unknown quantity and then allocate it a variable. So give it a variable, to rewrite it as a variable such as X, or honestly, you can use any variable you want. And the reason why you can use any variable you want is on this step, we must define our variable. So whenever we write a variable, you must tell me or the reader what exactly does this variable represent. So we're defining it. Then we'll look at the problem and we'll translate it into an equation. This may become step by step, it may be piece by piece, or you may be able to look at it and do it all at once, but it changes from problem to problem. Step 3 is just simply to solve for the equation by isolating the variable. So something we've been doing this entire section. We're just going to solve for it. Step 4, this is an important one because a lot of times when people make mistakes with word problems, you can tell if you just kind of just even logically think about your answer. But one of the ways you can do that is you can actually check your solution, so you can plug it back in that it satisfies the original problem. But if you made a mistake with your translation, also ask yourself, does this make sense? If we're talking about the number of people who bought tickets to some game and you get negative as your answer, does that make sense? No, because we can't talk about negative people buying a ticket. So not only are you checking your solution, but you're also asking yourself logically, does this make sense? And then the last step is I want you to write it in sentence form. So you're going to describe how the solution relates to the original problem. So for instance, back to the kids buying tickets. If we had 5 people bought tickets, we would say 5 people bought tickets to the game. All right, so now we're going to go ahead and get started on solving some problems. All right, so for this one here, it says when a number is trebled. What trebled means, it's another way of saying tripled. It's just past tense, but we can say tripled. I'll always use tripled in any of your tests. But when a number is trebled and subtracted from 7, the result is negative 11. Find the number. So first off, we're going to use a variable. Let's just use X. So now you need to tell me what X represents. So we're defining it. So X represents a number. All right, this one's a little bit different because it is going to be using what you guys are used to, but X represents a number. All right, now from now on, we can just say X instead of a number because we've defined what it represents. So when a number is tripled, so we represent tripled because if I give you 2 and I ask you to triple it, you need to multiply it by 3. because that would be 6. 6 is triple of 2. So that means we can rewrite it as 3 times x. And then it says it is subtractive, so n subtracted. So it's telling us this number is the number that's being subtracted from 7. So we need to subtract 3x from 7. Remember, whenever we see the word is, that represents equal, so it says is equal to negative 11. And now we've translated this. So we're just going to solve for a variable. We need to isolate our variable, so it's being added with 7, so we'll do the inverse operation of both sides, so we subtract 7. So negative 3x is equal to, well, negative 11 minus 7. When we're the same sign, we can just add them. And then whatever sign we have is a sign that we use, so it's negative 18. And then we'll divide each side by negative 3x, or by negative 3 to isolate our x. And our final answer is x is equal to 6. So the way that you will write this is you will say the number is 6. All right, this one is a little bit odd, I would guess you would say, because of the type of problem that we have to write it in words, but that would be our answer. All right, now the next problem says Sarah's father is now 3 times as old as Sarah. In 13 years' time, Sarah's father will be twice as old as Sarah. How old is Sarah now? So if you notice, we keep saying that Sarah's father is 3 times as old as Sarah, so that means we should be representing our years, or what we're going to talk about, as Sarah, because we're using Sarah to describe how old Sarah's father is. So I'm going to say x, and I'm going to say x represents Sarah's current age. Right? So, because he's now 3 times as old. So Sarah's father is now 3 times as old. So the reason why I'm not saying x represents Sarah's father's age is because his age is determined based on Sarah. So we're going to use whatever is running or is going to determine the other numbers. So whenever you see something is being determined by another value, we're going to use the value that's determining it all. So her father now is 3 times as old as Sarah. So the way we can represent 3 times as old as Sarah is 3x. And then it says in 13 years' time. So what that's telling us then is we're now not talking about now. Now he's 3 times older. We're going to talk about later. So we need to also say, well, if they're the same age now, they're going to be the same age later on. So we're saying that it's equal to. And in 13 years' time, Sarah's father will now be twice as old as her. So I can represent Sarah's father's age by 2x, but we moved 13 years in the future. So to represent that we have gone 13 years from now, we would have to add 13 to it. And now we just go ahead and isolate our variable. So we would subtract 2x on both sides. And x is equal to 13. So that means Sarah is 13 years old. All right, that is it for this one. And we knew that we were talking about Sarah's current age and not her father's, because her dad's age was determined by Sarah's. All right, let's move on to the next one. All right, this is actually the last question that we're going to cover. Real quick, when you are solving your question at the end of the video today, it was hard for me to find a word problem that had multiple choice. So I'm just going to give you one of the questions from the book. When you answer this, do not write it in sentence for right now, but just give me the value, the number value. I just want to make sure you can solve for it. On your work, you should be writing it in sentence form, but for right now, just give me the numerical value when you go to submit it. So that way it's easy for me to check if you got it right. I don't have to read the sentence. I just want to check to make sure you guys are able to solve it. All right, so let's go through this last question. I invest in oil shares, which earn me 12% yearly. So what that means is if I invest $100 and it earns me 12%, to figure out how much I made, I just multiply it by 0.12, which is the decimal value of 12%. And that means that will make me $12 for the year. So whenever we're trying to figure out how much money that we're making, we just simply multiply the value that we're investing by our rate of return, or how much it earns us. All right, so it's important for you to know that before we get into this. So I invest in oil shares, which earn me 12% yearly, and in coal mining shares, which earn me 10% yearly. If I invest $3,000 more in oil shares than in coal mining shares, and my total yearly earnings amount to $910, how much do I invest in each type of share? All right, so once again, you have to notice our oil shares are determined by our coal shares, because we are investing in $3,000 more in oil shares than coal mining shares. So that tells me whichever one is determining the other, which means coal mining will determine how much we put in oil, is the variable that we're going to represent. So X represents the amount of money invested in coal mining shares. All right, next time I'll pause that video and then write that out. All right, so now if I invest 3,000 more in oil shares than in coal mining shares, that means it's 3,000 plus X. And I'm also investing in coal mining shares, because how much do I invest of each type? That's telling me I'm investing in both. So I'm going to write plus X. And I know I've made $910. I'm not finished yet, though. Right? One of the things you have to remember is how much you're making in each investment. So in my coal mining shares, which is this here, I'm making 12%. So that means whatever I invest in this, I'm multiplying by 0.12. And then whatever I invest in my, this is oil, and whatever I invest in my coal mining shares, I'm making 0.1. So I need to go ahead and multiply this. So 0.12 times 3,000 is equal to 360 plus 0.12x plus 0.1x is equal to 910. If this were a question on your test, I would let you use a calculator. I wouldn't, or I'd make it nice and easy decimals that you can use. All right, so then we would go ahead and subtract 360 from both sides. And we will combine our like terms here. So 0.22x is then equal to 910 minus 360. So that would be 600. So that will be 550. All right, so then we will then divide by 0.22 so that we can isolate our variable x. And x is then equal to $2,500. So that means if we go back, X represents the amount of money in our coal mining shares. So that means so let me just pause this and I'm going to write out our sentences. All right, so that means we invested $2,500 in coal mining shares. And then our oil share, remember, is 3,000 more than that. So we would then do 2,500. We would add 3,000 to it and get 5,500. And now we need to write out our sentence for that one. All right, so the way that I would want to see this written is we invested $5,500 in oil mining shares. All right, this is important. I want to see you guys writing it in full sentences. All right, so that is it for this video. Remember, just give me the answer, though, when you're giving me your answer on Edpuzzle.